And now we move to project quality management, an interesting knowledge area within our terminology and our thoughts about project management, because it really is a above and around project management and what we do. It's important to understand that in quality management, we're not simply talking about making things good or better. It's about the whole concept of being consistent and bringing consistency to the process of building services and products through projects. With this, we have 3 different processes. We plan our quality management, we put some ideas around it, we perform our quality assurance, and then we control quality. So in planning quality management, we start with our inputs. First, our project management plan. We have our stakeholder register. Now, why would we have a stakeholder register in the inputs of quality management? Well, they help to define what it means to be of good quality, both in what we're trying to bring out as products and services, and they're very strongly a part of that whole process. How much do we want to spend? We've talked earlier when we dealt with budget about the price that we're willing to spend, the cost of quality. And that's where we start driving it from, is from our stakeholders. What is important to them and how do they want to participate in that cost? Our other inputs include our risk register. Again, we'll talk risk, but in risk management, we create that risk register, that table that we haven't looked at yet, but most of you know risk. We talk about risk in projects all the time. Here we need to make sure we include risks in our planning of quality. We have our requirements document, of course. We need to understand what it is in as much specificity as we can. Again, what we're trying to deliver, product or service. Here we need to have our requirements documentation to refer to as we plan how much quality or replan. Remember, these plans are done concurrently and they are all part of our project management plan, our whole strategy of how to manage a project. So they shouldn't be new or different or remarkable at this point. Our inputs need to be part of a whole effort that we wrap around the project. We have our enterprise environmental factors and our organizational process assets. Very important pieces to understand how we are moving forward. And it's important to know that, especially with quality, we need to know what our corporate values, our industry values as the way we go about it. Because we can't have our quality be managed outside of that. The quality of all our projects need to be part of a whole, which our enterprise environmental factors, our organizational process assets represent. So our tools and techniques, we have cost-to-benefit analysis that we use. We use straightforward, how much does it cost? What do we get out of it? What's our benefit? We use the cost of quality. How much does quality actually cost us? to have quality as part of what we do. We have our 7 basic quality tools, and we'll talk about them. We'll give you some, this is one of these places within this methodology, within this talking about project management, that we will fill your toolbox with different things. We have 7 basic quality tools that are used both in the quality field as well as other fields. And they're important things to be aware of. Use them as you need them. Again, this is not about having a tool that says use it every time. It's about having a tool that is useful when you need it and knowing the ability to choose it, to use it when necessary. We have benchmarking as part of our quality management idea. And it's important to know that we benchmark certain things, and especially if you're working in an industrial or a situation where you're building products, that benchmarking is much more done, understood, and acceptable. In other projects, benchmarking may not be something that you've either heard of, nor do you think you would use, or you might not use at all. But it's an important tool to understand within this context. We have design of experiment. It's a tool of understanding how you would take an idea and design a way of testing it. An experiment is simply having an idea. This might work. Well, how do I see if it will or not? Or have a clue? Can I do something that will demonstrate it? And that's what an experiment is, and we'll talk about that concept. Sampling statistically is a tool in quality that helps us understand if things are happening on a wider scale. We sample statistically when we're trying to figure out what the greater population of things are doing. And so statistical sampling happens to try and look at a small piece that's representative of the greater. And then we extrapolate how the greater population is doing. We have the tool of a lot of other planning tools. There's huge amounts of work. When you think quality, you probably heard the concepts of Six Sigma and different methodologies out there. Dimming will be talked about. There are huge amounts of things out there that are tools. And when I look at seeing and adding this as part of what we're looking at, quality management is about trying to find how to be the best at what you do at all times. Bettering both the product going out, but your process for bringing the product. And since project management is so process-oriented, and we talk and want to do better things every day, there's not any tool that's not, if it can help you, that we won't look at and embrace. Meetings are another tool. Can't have quality without meetings. Project managers like to have things consistent, and we will use our meetings to do that. Our outputs, first is our quality management plan, part of the project management plan. And this quality management plan, as this output, is that piece that says how we will approach, how we will manage it. It's not necessarily all of the detail, but it is the plan for bringing that in. We have the process improvement plan. Now, a process improvement plan is somewhat outside of a project management plan in that if we see things that we can do differently, we may present that, or we may advocate that we do things differently. Process improvement is something that companies are doing regularly. And so we have this as an output because we want to feed into the normal organizational structure and how people are viewing success. We have our quality metrics, and our metrics are specific to the project, specific to the organization, and we need to understand what they are expecting. So when we plan, we have metrics, and it's like a template, if you will, without being too strict to that word. It's not a form, but it is an understanding of what things are being measured and how they're going to be measured and when they're going to be measured. We also have our project document updates, which are very important to keep everything in order. Again, every time we change something, every time we plan something, we update the documents for the project. So the benefits of quality. If you do quality work, if quality is a piece of it, there's less rework. That should be obvious. If I am working hard and I'm trying to work on quality, then I shouldn't have to rework a lot of things. If you're building a product or a service, if you've worked hard to make it right the first time, you don't have to work to make it a second time. So there's less rework associated. There's also, when you focus on quality, you tend to have higher productivity because everyone is focused on doing the right thing and doing it the first time. So that there's more of a sense of productivity, that there's a value in productivity. You also drive down costs. Productivity and quality and less reworks drives down the costs of everything we're doing. Time is money, and any time we spend on things that are not part of the initial focus of a project are going to drive down the overall cost of the project. When you look at quality and the benefits, your customers are always in a focus because customers benefit from you being more efficient, being better quality, bringing the product to them, the service to them efficiently, and you optimize that relationship. So customer satisfaction is a huge piece of quality. We have concepts of quality when we talk about project management, and it's important to understand that there's a lot of diversity in it, and it comes out of the concepts of many different people in manufacturing. We have continuous improvement is one of our concepts, and this is from Deming. A lot of people have heard of Deming. He was a pioneer in the ideas of quality within a manufacturing environment. He went to Japan shortly after World War II, and he looked at their processes. He brought it back, wrote lots of articles and books upon the idea of quality, how to build quality. His basic concept, which was not his original, but he made it very much a part of him was the PDCA. PDCA is Plan, Do, Check, Act. And it is fundamental into this kind of philosophy or methodology or standards that we look at in project management that you are certifying for. And the PDCA, Plan, Do, Check, Act, is a circular type pattern. You plan what you're going to do, you do it, you check to see what you've done, and then you act accordingly. Think about what we've talked about so far about project management. Isn't that what project management does? It plans our activities based on the scope, on the schedule, on the cost, and then when we start to execute, we do things. We check, we monitor and control. We monitor and control, and we loop back and make sure that what we originally planned to do, we actually do. Another name in the continuous improvement realm, and the idea of continuous improvement is so known now, it's hardly worth talking about in terms of, well, quality is about trying to improve continuously through time. Malcolm Baldrige, in his Performance Excellence Award, was a major contributor to this idea. Because of the award and the name associated with it, it's something that manufacturers especially look forward to. They look at as a guiding light. The Capability Maturity Model, CMM, is another place where continuous improvement is rewarded, because when you seek to be part of that realm, when you seek to be associated with the capability maturity model, with continuous improvement, you're looking at it continuing not only the quality, that you have first-rate quality in your products and services, but you're also looking at the processes in which you create those products and services in your products. Where this comes out of is the development of products in a manufacturing environment, so it has a feel when you read the documentation of being about widgets. And a lot of project manager talks about widgets. Well, we're creating a widget. And how do you create a widget? And how can you create a better widget? And how do you create consistent widgets? So they're all the same size, all the same shape, do the same thing. The idea here in quality with project management is deciding on what you're going to do, first off. So the what is important. What are you doing? That statement of work, broad case. That charter, broad case. That work breakdown structure, more delineated. At some point, you have to decide what the process is you're creating for the what. And then you have to decide on how you're creating how I'm going to get there, the activities, the schedule, the cost of that effort through analyzing what you're trying to do, how long it's going to take, and what resources you need. But in that process, you have a concept of quality that you need to keep in mind. How are you going to maintain that process? With the capability maturity model, what they're saying there is that you can mature to have more standardized processing through time. Meaning, if I always have a project charter and I have a documented work breakdown structure, if I have sign-offs between certain phases of the project, if I'm doing a development project, it may be between the requirements sign off. I have a sign off there when the requirements are done and approved, to the design of the application, to the development, to the testing, out of testing into production. These are concepts that the capability maturity model looks at. And if they're repeatable, because remember, in the manufacturing world, where a lot of project management comes out of, the thought processes come out of, we're looking at repeatable processes and what we might call now operational needs, things that help us operate better. With the capability maturity model, what this is looking at is modeling and giving a company a score according to their maturity. And maturity is ranked by the repeatability of the processes that they have, so that their model of doing what they do is either mature or not. Project management can be looked at one of those processes. How do we do it? And CMM lets us view it that way and can score us. There are people who certify strictly in being a capability maturity model project manager. I've seen it. It's out there. So the idea of quality is both in terms of creating good product, but in this sense, in the project management sense, it's really, have you decided what you're going to create? And do you do it in a mature and capable manner? And I focus on the capability maturity model because it really encapsulates a lot of what we talk about with quality in project management. It's not about the shiniest and best. It really isn't. We don't want to gold plate. We don't want to offer more than is committed to. But we want to deliver on what we commit to. So in a word, quality in project management is about facilitating the definition of what it is we're supposed to do, when we'll do it, and how much it'll cost, and just delivering on that commitment. I am a high quality project and project manager based on my ability to deliver on that commitment. It's on time, on budget, on scope. Now, a couple other entities about quality, because they are things that you need to be aware of. Philip Crosby is someone who talked about quality in a number of different fields. And remember, project management borrows from a lot of fields, a lot of different things. It's not simply I do a project, I am a project manager. But Crosby, again, was in the manufacturing area. Do it right the first time. Do it right the first time. Do it right the first time is his concept. Philip Crosby put this forth, and it is associated with him. He is the person that was able to put into 6 words what a lot of people have said for a long time. If you make mistakes, it takes you time to fix them. So just do it right the first time. And he's known for that. That's the takeaway here that you should have. Duran is a writer and a consultant who used the term fitness for use. Now understand, we're talking about projects in their case that were product oriented, not service oriented, but still, the term works. If you're building something, it must qualify this quality assertion that it's fit for use, and its fitness is scaled to its fitness for use. Well, what does that mean? I mean, I can use a lot of things. I don't have to use them for any specific need. In project management, the way it fits is the fitness for use that Duran talks about is a idea that you have built it for a use. Does the product or service fit that use that was originally conceived? You need to look at it in the specifics, not in generalities. So, Duran, fitness for use. Kassan also talked in this continuous improvement realm and sustaining gradual improvements. So the idea is if you work in an environment for a long time, the idea is that you need to advocate and to support and facilitate continuous improvement. Kassan believed in continuous improvements. He wanted gradual and continuous improvements to all things around him. And sustaining those gradual improvements. So Kassan wanted sustained gradual improvements moving forward. It was the piece that he was known for. And it's the one that we need to remember, that he wanted to have these gradual improvements sustained. And what are we talking about? We're talking that it's not about building a box and saying, here's the box we live in, and going away. Here's the application that we have developed for you and going away. Not only do we want to continue our improvement of that box, but also the way that we created that box. Also how we developed it, built it, tested it. All the elements are within review of quality management. So we have Deming, key name. Plan, do, check, act. We have the Malcolm Baldrige, who has a Performance Excellence Award. You'll see it on TV. Cars companies use it all the time in their advertising. We have the Capability Maturity Model, which is a highly used and successful model of how we do project management and how we manage process and quality across many different industries. We have Philip Crosby, do it right the first time. We have Duran, fitness for use. And we have Kassan, sustained gradual improvements, continuous improvements. He's known for those concepts, and he pushes those forward. Other key quality concepts that we have is total quality management. Now, we hear about quality management a lot. How do we make things better? How do we make things pure? How do we make things work when they haven't been? How do we take a process and streamline it? All of those are concepts that we talk about in quality management. Total quality management is one of the concepts of trying to bring everything together. And TQM, or total quality management, is one of those things you'll hear about. And it's about it encapsulates a lot of the other people who are working in quality. and it brings together a lot of ideas. The concept here is that we're not simply a standalone quality management organization. Project managers and program managers and the project team should all be working towards a quality product and a quality process as we work forward. Voice of the customer is another of the concepts that are talked about in quality. Now, think about it. Voice of the customer. What are we trying to do there when I use that concept? If I were to look at you in a neutral environment and say, what is the voice of your customer? What would be your response? Think about it. Here, when we're dealing with quality management and quality concepts, voice of the customer is by building a secondary customer beside your real one. But you build them. Well, how do you build them? It's kind of like a mannequin. It's kind of like a doll, a model. It's a construct. It's a construct of what your customer is. And the voice of that customer is what you put in their mouths based on what you know of your customer. It's a very important construct. It's a very important model to have in mind. Especially if you're dealing with a lot of customers on the outside. If all you have is one customer and you can clearly define it, it is relatively easy. But the multitude of customers in different demographics and with different needs occur, you need to have this concept. Why? Because we're working towards quality, we're working towards consistency of product, service, and process. And being able to at least construct the voice of your customer, the questions they may ask, the issues they may view, they may bring up, is important, because if you can plan to answer their questions, to alleviate their issues, you have a better product that would be better accepted. So the voice of the customer comes from that concept of building a construct of the customer and then listening to that construct and challenging yourself to build a better one for the next go-round, whatever that means in whatever world you live. These aren't real people. This is business. This is organizational work. Remember that. And we're dealing with quality. So the more information we have, the better we can make the quality. We have design reviews. And design reviews is a quality concept because we want to know what we're trying to do. So let's pose two different things on design reviews. One is an application. So it's a service, let's say, that we're presenting to the customer. And the design review in that case could be as easily as having the designers and the owners of an application roll out that design and allow people to see it, customers, potential customers, so that they can make comments about, does it fit the need that they saw? If it's a point of sale system, do they get the ability to sell a product? Do they track the sale of that product? Do they get customer information? And if so, to what degree? And does that degree fulfill the need of the person who is seeking that information? Is more information necessary to be added to the requirements, to the application? So that's a service. If it were an item, and you're designing and you want to review this item, Say the item is a watch, and you look at this watch and you go, show me the design. And someone puts it on their wrist, and they look at it, and you go, no, you can't do that. And they look at their watch, and they look at you and they go, why? And the designer says it must be on your other hand. Why? And they say, because you're right-handed and your watch must be on your left hand. We've designed it to be a left-handed watch. And as I look and review this design, I go, that's great, but I'm left-handed, so a watch on my right hand would be more valuable because that's where I wear my watch, not my left hand. So, and typically watches can be worn on either hand, but it's known that left-handers wear their watch on the right hand and right-handers wear their watch on the left hand. It's to keep them out of the way. There's several reasons why convention has that. My point is two things. One, there are conventions that you deal with in design. And in the review of a design, you can find those conventions and deal with them. Either reject them, which is fine, or accept them and change the design. And the second thing is, when you deal with the design of an item, you just find out if it works in a way that is acceptable. And there's details in there which I won't go into, but you can look at the design and it makes sense that when we're dealing with an idea and a concept of quality, we need to look at the detail and we need to ask questions about the detail and what is being done. How is it being done? Now, another point that Six Sigma, and I'm pausing a little bit to you and I'm taking you all in because Six Sigma and quality are equated together very closely these days. Six Sigma is the concept that you want all your projects to be within six standard deviations of the norm. Meaning, if you're within 6 standard deviations of your normalized value, meaning your acceptable rate of failure, of success, however you're judging that, the Six Sigma has become a poster child of being of high quality. With projects, it's become not only a certification and part of certifications, it's also something that we talk about and understand. We are talking about raising the bar, being more process-oriented. So we have higher and more consistent processes. And so Six Sigma is seeking a perfection. Now, Six Sigma is not talking perfection. It's talking about being within a few fractional percentage points of perfection to be its goal. But it is not something that says you have to obtain that perfection or that goal. Six Sigma is, in our world, is very valuable because it's focused a lot of people's minds on the idea that A, quality is important, and B, that the process that we go through is as valuable to us as the products and services that we bring to people. Now, if you have a bad product, a bad service, you're going to fail. And no wonderful process guru, Six Sigma, waving a flag and playing magic with it will help a bad product or service. Don't get me wrong. But Six Sigma has focused our attentions on the product, service, and process. And there's nothing wrong with that. It's good. We look at Six Sigma these days, like I said, it's a separate certification that people will go through in different levels. The last thing I want to talk about in this concept discussion of quality is just in time. Just in time is a concept that comes out of manufacturing. And it is talking about not warehousing or transporting things and then warehousing them. It's getting items when you need them. Just in time, it was founded in an idea that if I'm building a car, I don't need the tires to be delivered to me 10 days earlier so I can just stick them in the corner. It's talking about delivering things when you need them so you can install them, you can use them, whatever that thing is. And why is it part of quality? It's so that we don't, there's money in warehousing, there's money in storage. And what Just in Time tries to optimize is the concept of if I need something, I want it here. I have this going on in my personal office. In my personal office, I agreed to getting laser printer toner packages. And I chose to get a number of them at one time. And so I did, and they were delivered, and I paid for them. Now, I'm still not using, I'm like 2 in, because I don't do a lot of printing at my personal office on that printer. And I get calls that say, you know, you want more, you want more, you want more. One of the ways I deal with them is I say, look, you sold me too much. You didn't ask me what my need was before you sold this. You just wanted to sell it. Well, that develops a bad feeling from me to them because I feel like they're not listening to my needs. So the quality of what they have done has been detrimental. Now, I think the product's fine. I have room to store it. But imagine if we're not talking about a stack of things this big. If we're talking about a gross, which is a dozen, of hoods for a car, or tires, or cars, it becomes difficult to deal with not getting things when you need them, but getting them and having to store them. Storage is a huge issue within manufacturing especially, and within other organizations too. I know of one organization that does not have the business right now to create certain products. So what did they do? They took one of their manufacturing areas and they turned it into storage. It wasn't an active thought process. It was a process that they did because they didn't have enough business to validate keeping it open, and they realized they needed storage. Why? Because they had things that are sitting around that needed to go places. They had items. They had furniture. It happens in all businesses. So the idea of a quality concept of just-in-time means get something when you need it. Don't get 15,000 candles when they're on sale if you're stuck storing them. Get them when you need them. Think about it in business sense that storage has a part of storage is the expense of it. And yes, I bought 15,000 candles at one time. You know, I had storage in a basement till it flooded. But it wasn't the smartest thing I ever did. And that's the point. Quality management is the concept of doing smart things. So we're not spending money on bad things. We're spending them on the things that count the most, on making money, spending the corporate assets, the organizational assets for the things that matter the most, that we can see a return on, that makes us money, that saves us customers or keeps us out of jail and keeps us within compliance. Next, we'll talk about the difference between precision and accuracy. They sound very much the same, and most of us use them very much in the same way, but they have a little bit different take. Here's what we're looking at. Precision means that if something is closely clustered together, think about, I have precision if I can take 16 darts and I throw them at the wall and I get them clustered near the target. Whether I hit the target or not is not important as much as it is that I cluster them. My throw is precise. I get a goal of putting them close to the target. Accuracy, on the other hand, is near the real value. So if I am accurate, if we talk about being accurate, then we're talking about being near the real value you're shooting at. Now, the cluster may be good and accuracy may also be good, but they really mean different things. They mean something a little bit different to different people. If you're dealing with large populations and you're trying to say how many people arrived at home, well, you may want to know the precision, how closely clustered they were to their house, as opposed to the accuracy, who actually got in the door. Now, that may sound silly, but if we're dealing with the precision of building things, building widgets, cars, computer chips, do we want to be precise? Our precision is what we're looking at, or accuracy? And they're not mutually exclusive. It's just a matter of quality. Remember, we're dealing in quality. So is it more important that we're 100% accurate or we're precise? We're close. We're in that ballpark. If you're dealing with a computer chip, it better be accurate. If being close means that it won't work. There again, if we're dealing with a computer mouse, perhaps it's good enough if our precision numbers, it's precise. It works most of the time. It's close enough. It's a matter of what's important, and how we value that importance is important to how we look at the quality of the products or services. So you think of our products and services and our quality of those products and services as either being precise, accurate, both, but they're different. These are different ideas that we need to keep in mind. You can be precise and not be accurate, and vice versa. Now, a couple of things to think about. Cost-benefit analysis in quality. Why is a cost-to-benefit or a benefit-to-cost analysis even in our planning? Why would we even think about it in planning quality? Well, it's easy, in a sense, because we're really talking numbers, right? We've gone through the practice of knowing what we're doing, when we're doing it, how much is it going to cost. If we're talking quality in that scenario, then how much is this going to cost us? We mentioned earlier when we're talking budgets that there is a cost to quality. So why would a cost-benefit analysis be a good thing to have when we're talking quality? Easily put, it's because if we spend money on higher quality, whether that's developing better methodologies, processes for doing what we're doing, or developing a better product or service, that's going to cost money. And we need to take that into account. It's not a wholly set aside type of activity. It involves the whole project. And so when we look at quality management, we need to think about what kind of costs could we be adding to a project that may not have been thought about. And this is important. This is not insignificant. Because if we say I'm going to build widgets and each of them needs to be 3 inches long, and I have a quality management assertion that we're going to check each and every one, and I'm building 10,000. That's different quality assertion than if I'm building these widgets and I'm testing every other one, or every 10th one, or every 100th one, just to make sure. We're not testing all of them, but we're doing a spot check. Different levels of effort in the different scenarios. And each level of effort has a cost associated with it because it takes real people or real resources, depending on how it's done, to accomplish what you're asking. So it matters in the cost to the benefit. If I am taking computer chips, and I once built computers back in a crazy time, and I literally was in a white box factory where we would take the boxes and we would put the motherboards in and screw them down with the hard drives, etc., etc., etc. And I did this for a little while. It was a very neat experience, to tell you the truth. But one of the things I realized is that, the most important piece of that machine, that computer, was the chip, the smart chip that we put in it. Back then, I think we may have been beyond Pentium, but bear with me. It could have been a Pentium 4 at that point. But it was separate processor from the motherboard. The other smart pieces, one of the other smart pieces in a computer. And those of you who are not computer with me, it's okay. But think of having a chip that is this size be the most expensive piece of equipment. And if you had a fumble-fingered person bend part of it so it would not fit in the place that you put it, you didn't just throw it away. You had someone who was an expert fix it with a little pair of needle nose pliers, and it would work. My point here is that the cost benefit of quality, it was worth having someone trained, knowledgeable, and able and available to fix that small chip so that we could keep going and not lose it. We didn't simply throw it to the side. It was not what in fast food restaurants they do, which is just toss it off if something goes wrong with an order. Because of the cost benefit, because that chip cost enough to validate the effort and the time it took to fix it and use it. So in quality terms, cost-benefit analysis are important. There's less rework in having quality as part of your focus. So you want to look at the less rework quantity. You want to look at the higher productivity if you have high quality. If you have high quality, you don't have to, you have people doing better things and they're doing them well. That's valuable. In high quality situations, you have lower costs. Why? We didn't throw away the chip, we used the chip. We used it, we validated it, it was good. And we didn't have to, we weren't throwing things away. If it's disposable items, then dispose with them as you need to. But quality management and looking at the costs and the benefits of thinking about quality, we look at these less rework, the high productivity and the lower cost that it creates. Also, if you have quality, if you think of quality as something that is directly related to your customer, then you understand that the stakeholders, the customers, will have an increased satisfaction in the product, in the situation. It will help you. Now, I sound like a cheerleader for high quality in some ways, and I am. And high quality means not that you keep pushing better and better and better. It means that you fulfill what your obligation is. One of the problems that people have is that they don't understand that a $10,000, $20,000 vehicle may not perform up to a $50,000 vehicle, but it can be of a higher quality because of the value of that vehicle and because what it does is sufficient to meet the quality standards of that lower price. So value to quality is an interesting twist that we need to keep in mind in talking about this, thinking about this, because quality doesn't mean simply that a Mercedes has more quality than a Toyota. That's not the case. They're not apples and apples comparison. When we build projects, we need to understand that there is a time and a cost to quality, and that we try and build quality in, no matter what the public may think of how high it is or low it is. Quality in this sense is about, are we delivering what we had promised to our stakeholders, to our sponsors, our team, and are we doing it in a consistent manner with repeatable processes, with repeatable things? When you deliver things of high quality, you increase the profitability. Less rework, higher productivity, lower costs equals higher profitability. If you have less rework, higher productivity, lower costs, and your stakeholders are satisfied, you have increased profitability of whatever you're doing, whether it's a product or a service or whatever your project is associated with. The cost of quality can be looked at in a couple of different ways. One is the cost of conformance to avoid failure. Now, this really has to do with prevention costs. You're preventing things from going wrong. You're preventing the process from going off the rails. You're preventing things from happening. And there's a cost to that. There's a cost for overseeing and putting things in place and making sure that all of the various processes and procedures are upheld. There's also the appraisal cost, apprising yourself of all the detail. So you're looking at it, you're trying to figure out, not only saying you should do it, but making sure the people do what you have said to avoid. You're trying to avoid any possible thing going wrong. That's a cost that we need to look at. But then we look at the other costs. The cost of non-conformance. You're not trying to avoid a failure here. You're looking at this cost because of a failure. It's one thing to look at a car and try and make sure it's right, it's driving properly, and saying, yes, we have a high quality car because the engineering is well, the parts are good, the manufacturing and the labor was very good, and we have a good car. But what if you decide that you would rather not have the cost of conformance, but the cost of non-conformance? And that's when you have failures. So in this case, you might have internal failure costs. You haven't looked at it ahead of time, you look at it behind when it actually happened. So you're looking at it failed inside your purview. Inside your purview may be inside the factory. It may be that the wheels fell off your car before it left the lot, but no one had bought it yet, so it really didn't matter to a consumer, but it's still a failure. It's still, if you didn't check it beforehand, then you have a cost associated with that failure. You also may have external failure costs. Well, you can imagine in my scenario, if we're talking a car and it's bought and driven off the lot, that external failure cost could be extreme because people could be hurt, and no one wants that. But these are costs of quality that every project needs to think about. I once talked about a project that I was associated with years ago that was a medical systems conversion of data. It was a billing system at the time, but a lot of us are calling this medical information systems, or there are various names for them. But they have customer information and they have medical information. Back then, we did not have as much HIPAA type oversight. Now we do. Back then, we talked about it in our internal meetings and as I consulted and I talked to the people. And one of the ways we made people understand what we were doing is we were converting people's data from one system to another. The data contained some very pertinent medical information and some possibly not as pertinent. I mean, some of it, why were we worried? And I reminded the team, here's the word picture for you. If you convert a person's allergy status and it's a binary button that you start with, either they have an allergy or they don't. And if they don't, no more information is transmitted. And you get that wrong, think about it. Does this person have an allergy? No, when it should be yes. And that information is transmitted into billing records or other medical history records. That could be a fatal flaw, literally, if someone has a major allergy that you have not translated and transmitted in the conversion properly. In this case, quality could be life-saving in a very remote way. So it's important to understand what are your costs of conforming and non-conformance. In a less drastic way, I helped convert billing information again, but it was about records of who sold devices to whom. And it was associated with a commissioning system. Think about commissions. What does that mean? If I say I have not done my commissioning translation and transmission of the commissioning records properly to the proper system that pays people. Okay, the key there is pays people. In this case, we were getting a fallout in a billing system conversion of about 25%. Well, the company was paying a whole lot of money in commissions. And if 25% of those commissions were not being paid, that would mean a lot of heartache. So we had to up the idea of quality, and we drove the idea that the cost of non-conformance, of not doing it right, was so high to fix people's paychecks that we needed to convert that over to a cost of conformance and prevent it and appraise what we were doing. Now, there are 7 basic quality tools. We could have more, but these are the 7 that we generally think of as quality tools that are used. They are the cause and effect diagram, also known as a fishbone diagram or Ishikawa diagram. There is the flow charts, check sheets. There are Pareto diagrams, Pareto diagrams. There's a lot of pronunciations out there. Histograms, control charts, and scatter diagrams. We're going to look at each of these. These are some of that toolbox stuff that you can use. It's also these are also tools that we use in other ways, not just for quality. So it's important to keep an eye and think about how these could be affected and used, because they didn't come out of quality management. They were quality tools that some of which were developed for it and enhanced for it, but they came out of other areas and or used by people dealing with quality. Here's the cause and effect diagram. Note in this diagram, it's called an Ishikawa diagram because it was somebody who had created it first. But we look at it here. We would also maybe look at it in our risk analysis, risk management portions. But we have a problem. And here's how the cause and effect work. Your problem leads you to look at maybe this is the cause, or this is the cause, or this is the cause, etc. And then you detail out that cause and effect. The cause and effect diagram helps us understand and kind of decompose a problem into specific causes and understand where the effect came from. This could be, you could have one that states that the problem is that your drain isn't draining. Well, what are the possible causes of it? Well, think about it. Do I have food stuck in the drain? Yes or no? Do I have hair stuck in the drain? Yes or no? Is there a root that's causing my drain not to work? Yes or no? So there's yes and no, but there's detail. If I had this as a cause, if it was a root, would it be draining at all? Would it have standing water, etc.? So a cause and effect diagram allows you to decompose, break into pieces a problem, so it's easy to see where it may exist. It also works on the theoretical, so you can theoretically have a problem and you can decompose it and look at it in the what-if scenario. This is a SIPOC model. What does SIPOC come from? It comes from supplier, input, process, output, customer. So the idea here is to look at any type of activity and to break it into its pieces. So you may have a supplier. Who supplies the input? What does the input look like? What is the process the input is subjected to? What is the output of this process from the inputted information? And then who are the customers? Who owns this end thing? How do you think this would help you as a manager of quality? Well, it can show you where to look for quality. It can show you where to help solve problems, as well as understand any processes, inputs, outputs, customers, suppliers. If you do this kind of thing on your project, in any area of the project, it might show you more stakeholders. It may show you risks that exist. It may show you issues you already have. There's a lot of different variations off of this. Like I say, this is a tool. It's a good one to have in your toolbox, but how it's used specifically can be different to different people. Flowcharts. They define and analyze processes. They define and analyze processes. They show the flow of a process. We've all seen flowcharts. It's one of the reasons I don't show a lot up right here. We've seen them. We know that they show us and communicate how people are involved with the process. They standardize the process or can be used for that. Well, how would standardization of a process be a helpful thing when we're dealing with quality? Well, we've talked about quality is about having the right process used regularly, all the time if possible. So having a standardized way of looking at it is a good thing. Also, we can look at improving processes. We can improve the process as well as standardize it. And it helps when we see how information or people flow, where bottlenecks and trouble spots can come up. So flowcharts are great for showing the flow of information through processes, people, etc. We have check sheets. Check sheets is one of those things that we can use. It's usually a document, and it collects the data in real time, and it puts it in a location where the data is generated. What we're talking about is creating ways of capturing information, being more quantitative, quality. It doesn't matter the kind of data that you have, as long as you are putting this data in one form. A lot of people call these tally sheets of some form or fashion, but it allows you, say, a check-in sheet is a tally sheet. A check-in sheet for a meeting or a class. I trip over this one because I always pick up a tally sheet, a check-in sheet from a class if I'm doing this live. And I go, here's a check-in sheet. You see, here's your people, here's your checks you signed. It's a very informal but precise way to make sure that you have information. And the information with a check-in sheet when you're talking to class is, you said you'd be there, I got your name from the handlers, you signed it with your signature, I checked it off that said, yeah, you did sign it. And it gives us information that helps us build a more quality process moving forward. That's the whole point. It can be used in a lot of different ways. Check-in sheets are used, think of the shuttle or a moonshot or a TV show with a moonshot in it. But when they check the different switches and someone's there, you know, they say switch A and they go check and they check it off. Think about how that can work within your context. If you're building a project, you may have a check-in list of who's where when. I've used detailed check-in lists for deployments of code to make sure that certain switches are hit, certain interfaces are touched or exercised as we roll a certain application out. They can be very detailed, they can be very simple. It's just a tally sheet. And it's hard, I look at it and I go, it's so simplistic, and yet it's used so much. This is a Pareto diagram. This is the kind of diagram that we get the idea of the 80-20 rule. It was created to sort of bring that out. It's when it's associated with it. So if you hear Pareto or Pareto diagram, think 80-20 rule. The way it's used is you want to find out where the problems are. In this case, we have a diagram that has the average calls to customer service during the last week. Well, we found out that on Sunday and Monday, we had more calls than the rest of the week. And the idea here is it directs your attention to solve problems. So what's the problem we would solve here? Well, we know that Thursday there weren't a lot of calls. So we want to ask, what happened on Sunday and Monday that we had so many calls? And perhaps there was an outage, or perhaps there was something that happened that we can specifically look at. And we use this to help build the quality of our processes. Maybe we need more switch bandwidth on Sunday and Monday. Maybe we need more people to watch the lines or to fix the circuits. But this is informational with specifics enough to be actionable. And that's the point. But key 80-20 rule, Pareto diagram. Histograms are a graphical representation of the distribution of numerical data. That's all they are. What we see here is an example of where the data is color-coded, so each of the colors means something different. Each of the numbers represent a different type of scale, and this is just a way that we represent data. These tools actually are very good at helping us know what's going on, because a lot of us are visual, and the visual representation of the data is sometimes more powerful than just words. I've switched different ways of looking at it, and I've had people who like the word tools better because they could read the words and they could wrap their hands around the words. Some people like the visual graphic representation of these tools better because they're visual and they like to wrap their eyes around the tool and it gives them a better understanding. The histogram can have a lot of different flavors to it, but every period would be a unique period, noted here with tick marks. And the numbers right now I haven't given value to except to number them 1 through 6. So it gives you a sense of the look and feel of this without giving you a lot of cold data. Control charts. Now, these are used mainly in manufacturing type of environments. And what you're looking at here on the control chart is you have a upper level, lower level that are viewed as being the way, the boundaries of effects that you're charting in this. So it could be that you have defects low and high or heat low and high. Typically that's what they're looking for, but they want it to be around this middle line. They view this as kind of the medium. That's the high, that's the low, that's acceptable. What you're looking for here in a lot of control charts is called the rule of 7. If you have 1, 2, 3, 4, 5, 6, 7 events, 7 events that have happened on one side of that mid bar, then what you want to do is you want to investigate. It's called the rule of 7. That's where, if you've ever heard of the rule of 7, that's where it comes from. It comes from looking at events and saying 7 have happened in one side. That means we need to look at it. Does it mean anything's wrong? No. But it means that the quality of our process, the quality of our product may be at risk. So it's a way of looking at quality and being able to give it a bit of metrics around it using control charts. Again, here's another of those diagrams, charts, and here we see a scatter diagram. And what you're looking for here is where things come together, where there's multiple things that happen, events. And I know I'm talking almost esoteric and possibly mathematical, and I apologize a little, but a lot of these charts come out of an engineering and mathematical background that are used within the quality management field. And here you're looking for a pattern, a scatter pattern that you can investigate. Again, you're looking to see if there's anything wrong with our process or our product or our service that we're analyzing through this method. But these are tools that are obviously and used. These are tools that are used by professionals to look at the processes and procedures that are happening within a project. So, two other different tools that we talk about: benchmarking, which is the process of comparing one's business process and performance metrics to the industry, to the best practices of other companies. So you benchmark, you see, if we're doing it this way, can we compare it to someone else or to the industry? Industry best standards. We also look at the design of experiments, which is a statistical method for identifying which factors may influence specific variables of a process or a product under development. So you design an experiment, and it's a statistical way of doing it. And you look at factors that could identify. So it's a very specific thing within the realm of product and process development. A context diagram, which we're looking at, is one that has a process at the middle, and we see which external entities interact with that process. And here we see that they're interacting inwardly and outwardly, so that there is an input and output happening between the external entities. There can be context diagrams that have only one-way communication. We think about that, and we talk about that within application design, within product design, where the communication is one way or the other. I get information from you, or you get information from me, but it doesn't work both ways. When we look at communication management, we'll look at some basic communication models which could clarify how this came into being, how this kind of external entity to process and the context in which things interact with each other makes sense. So 8.2, we're managing quality management. We're managing quality. We're looking now to perform quality assurance. And in performing this, we have an input of the project management plan, the process improvement plan. We have quality metrics that we put into place. We have quality control measures. We have project documents, which may be pertinent to what we're talking about in quality, because quality of a project can affect just about anything within the project, from schedule to budget to scope, etc., etc. The tools and techniques are our quality management and control tools, and we've talked about a lot of those. Our quality audits. Audits are about looking at what's happened and making some judgments and determinations and observations. All of those are possible. Not all of them happen every time. So when we're looking at quality, we're trying to figure out, maybe spot checking what's happening and being able to understand, are we getting the quality that was originally proposed? We also have process analysis that can be used as one of our tools and techniques to do the quality assurance. From this process, we get change requests, we get project management updates, project management plan updates. We also get project document updates, which we get virtually every time we do anything. A process in our world, remember, is simply something we do. We perform quality assurance here. and our organizational process asset updates. Our assets that the organization maintains can always be updated. So here's a few of the tools, affinity diagram, and this just shows us how things can be organized. You have a superheader, subheaders, and ideas. You can create these, and this is a very rudimentary one, and also it can look complicated because what we're saying is we have ideas under each subheading, and they may be equal, they may not be. A lot of times they're not. I've made this one look pretty so you can see it, but realize each subheading, there doesn't have to be 6 of them under each superheading. Each of the subheadings may not have this many ideas under it, but this gives you a feel for when you're trying to figure out what certain elements may be, a tool to actually work with them. Tree diagram, and I like all the leaves off the tree, don't you? It's a fall tree diagram. And the idea of as much as I put things into the previous diagram, the affinity diagram, I took them off of this. The idea here is to keep your tree diagram extremely freeform. So you go from an original concept, whatever idea you have, and you branch and branch and branch and branch as much as you need to, as little as you need to. That's what a tree diagram is. A family tree is a classic example of a tree diagram. You've seen them a lot, so I don't feel like I need to show you too much about it. Understand it is branching according to like subject matter. In a family tree diagram, you would move along relationships. That's the common thread. In a tree diagram in business, it may branch amongst business units or organizations. Quality audits, now this is a process for systematically examining the quality system and carried out either a internal or externally quality audit by an internal or external auditor. Now, the idea here is that a quality audit is trying to see what exactly has happened or is happening within the project. It can be process audit, it can be a product or system audit. A lot of this quality concept that we're talking about comes out of a manufacturing mode. Now, as we've talked, projects have a beginning, middle, and an end. A manufacturing site doesn't necessarily have a beginning, middle, and an end the way a project does. We use and developed project management techniques within the manufacturing realm, but in that realm, we have widgets going out constantly. And so they think in terms of quality as creating a better process and a better product and replicating it multiple times over. Here, we're looking at quality within projects as having a project methodology, a formal way of approaching it within an organization, within a project management group that can be replicated, that can be moved forward, that is consistent. Quality audits can also have to do with the product or the process that is the object of the project. But right now, we're looking at this as more about the actual methodologies that we're instituting within the project management field. So to control quality, here we have the inputs of the project management plan. We have our quality metrics. We have our quality checklists. We also have our work performance data, our approved change requests, and deliverables, as well as the project documents, which are always present. Here we're pointing them out because they may have pertinent information. Organizational process assets give us the landscape from which we work in terms of quality. Our tools include the 7 basic quality tools that we've talked about before. We're now performing quality control. And in performing quality control, we need those tools to be re-looked at and re-investigated. They were part of what we initiated as saying we need these tools. Here, we're actually using them more than in that management or planning of the management type of phase. We have our statistical sampling, which when you're looking at quality, you may be taking the statistics of what you're doing. You may be looking at the process or product that you're creating, and even before it's released, look at statistics based on it. We also may be inspecting those products or services, looking at and seeing what we're doing so that we have a very concrete understanding. And we looked at approved change requests and reviews of those. We want to know in the change management realm, when we're talking quality, did we avoid dropping the quality when we changed anything? Did we introduce things we need to look at in a change, in a quality kind of mindset? So we're going to look at the approved quality reviews and the approvals, anything that's changed through that process to make sure that everything is in line. Controlling the quality means we're keeping up with what has happened. Controlling the quality can include things like testing the code, okay? Looking at the product. If we were building a house, it would be inspecting the construction, which is really what, when you're doing software testing, you're doing. You're inspecting the software and construction. Our outputs include our quality control measurements. We have validated changes. So we've validated the changes that have been introduced. That's part of the quality control process. We also verify deliverables. We check to make sure that everything that was put into the work breakdown structure, all the deliverables that we said we would do, are being done. Remember the requirements traceability matrix. In this stage, the control quality stage, we are verifying and validating all things. So we might be looking back at that and probably going to see it on here as a output. If not specifically, then we will as part of the project management documents. We have the work performance information. Again, noted earlier, we get data on the input side, we work our tools and techniques, we get performance information on the output side. So we see what's happening, but we interpret it with tools and we output it to the appropriate place. We get change requests. Even now, we may see that changes need to be instituted, need to be put out there. We get project management plan updates. Like I was saying, things get updated. And project document updates. Organizational process asset updates as well. So that's The quality management. We plan, perform, and control quality. There's a lot of moving parts, but understand it doesn't mean that the moving parts are, there's a lot of them. There's a lot within them. There's a lot to be thought through, and quality is one of those things that people spend a lifetime working on, because quality is something that helps us better our processes, our procedures, and our projects. Our key review items: continuous improvement, TQM, total quality management. We have the cost of quality. We talked about the CPOC model, our cause and effect diagrams, our Pareto diagrams, our affinity diagrams. Key terms to understand and remember when we're looking at certification, we're looking at taking a test. These are all key things out there.